So I will be with you, taking care of you. As Paul said, Claire Edelgren, and I have the great pleasure to introduce the first session for you. This session is going to tell you a little bit about what we've been doing in the supply chain space. And it's pretty exciting POCs that I think are really pushing some of the boundaries of what's been possible before. And that's what we always like to bring to the table at this event, is to show you where we're at. Do we think it's all the way to production? Of course not. Right, it wouldn't be the latest greatest if we were all there and it was already and scaling. But introducing this panel discussion demo, a little bit of all three, I think it is. It's really one of our most experienced and absolutely knowledgeable blockchain product specialists from our team. Federico De Polo, I think probably have been here, I don't know, the longest perhaps of everybody. He really knows this space, and I think it's a great privilege for us today to have you with us and to share some of what you've been working on.
Yes, indeed, and thank you, Claire, for the very nice words and the very nice intro. Today we're going to be going through transforming supply chains with blockchain technology. I am delighted to be joined today by Karen Scarborough from Microsoft. She's a senior technical program manager, and she's also an executive director at the Ethereum Enterprise Alliance. And she's going to tell us basically how Microsoft has started doing a first splash with privacy technologies for supply chains. And also my colleague and product owner for tokenization in OpsChain, Vito Domizio, is going to be with us and is going to tell us the latest updates on the product, as well as a very nice demo. So we're going to get started pretty soon. I just have to let the CPE eligibility go through. And also what I want to anticipate is we're going to be going through several topics today. If you have any question, just drop it in the chat. We're going to be taking some Q&A at the end of the session, so don't be shy. So as I said, today we're talking about transforming supply chains with blockchain technology. Before we start, a quick disclaimer. What we're going to see today is for educational purposes, and it's not financial advice at all, because we're talking about supply chains. So just stay with us. It's going to be very interesting. So let's take a first step, and I'm going to walk you through how the blockchain technology could potentially transform supply chains in today's world, which is a very important and tricky aspect. So there is a lot of challenges in supply chains. We need to do efficiency. We need to make them more effective, also be more connected. And we have also some pressure coming out of regulations. We're going to see that soon. And what we're going to want to see ultimately is how we can go over those challenges and use technology to try to make supply chains better. So the regulatory compliance is a very evolving landscape, but it's been like pushing hard for the last 5 to 6 years. And it's going to be more and more as we move through the different years across 2030, basically. So from 2019, we got CS-DDD coming into effective, is due diligence directives, which is basically forcing EU companies to start to think about the impact of their actions in terms of sustainability and corporate responsibility. 2024 was the year of the United States Prevention Act for forced labor. And 2025 will be the year for the deforestation regulation to come into place. It's going to start for large companies. We're going to move into small and medium companies by 2026. In between those things, we have the Corporate Sustainability Reporting Directive, which is going to basically force companies not to just think and do things, but also to report what they're doing publicly. And the final thing that we see, at least for now, and it's a very important piece, we're going to see why, is the Digital Product Passport, which is right now an EU initiative. It's going to be due by 2026, and between 2026 and 2030 is going to get fully effective. But we will see that this is going to transform how we do products, because we have to trace pretty much everything in order to be able to comply with that directive. And if we think about blockchain, why blockchain could support those kind of regulation and compliance pushes? Because basically blockchain gives the possibility to do end-to-end traceability across the supply chain. So we will start from the very beginning, raw materials traceability, through the manufacturing, until the distribution process, and potentially also on the final piece of, let's say, selling the goods to the customer. So what we need to do to be able to do that is create some digital twin of the real world assets so they can be traced from the very beginning, attaching all the information about the processing and the steps, and be able to track how they move, how they are combined into different byproducts and the final products at the end, how they are transformed. And doing that can give us a couple of benefits. Number one, I can prove to my B2C customers what's the product, let's say, story, and give some transparency, which is always important, especially in the current world. Second benefit we can get is doing some kind of passport of a product for business to business, so B2B use cases. Because if I am buying something, I want to make sure I don't have critical raw materials coming out of very bad regions. I want to make sure that everything was done as expected. And we do think that blockchain can be the technology supporting that through tokenization and also through moving those assets across the supply chain. So it looks very nice and good until that point, but we can think that we might have some challenges to address, and I'll tell you why. So until now, using public blockchains was something that was done by several companies. We can mention a few, like, for example, Peroni, the beer company, tracking the batches of beer and all the raw materials and byproducts through the use of public blockchain. But that was done at the batch level. That means we're not disclosing how many bottles Peroni is producing. We're just saying that the batch of production has been traced. And that, of course, created another problem, which is I don't have any visibility of the goods. So once they are done and packaged, I don't know where they're going because I'm not tracking the single bottle, I'm tracking the batch. And having that lack of visibility creates another problem, which is how can I then aggregate the data and provide the right level of visibility in the supply chain. So starting from, for example, the final processing back into the supply chain. So those three issues create a need, which is a need to improve the current situation and a need to create something new, which can support going beyond those limitations. Technically, we have to find a way to do so. And to do so, we have also to think about a couple of areas. So the first one is how can I preserve confidentiality of my tracking, of my asset tracking, but on the same time, I want to prevent double counting and potentially double spending of those assets. So we need to find a way to do that with blockchain, but also with privacy. The second challenge that we have is how can I give selective visibility of assets and of their history, which is a big topic. We're going to come back in a second once we walk through those in details. But basically gives us a challenge to solve, especially in complex business networks, because those complex business networks have multiple suppliers. They are challenging each other in the competition landscape. And it's difficult to make those suppliers work all together because they will need to do complex integrations, like, for example, ERP integrations. And this is the third issue that we have to address. So if we go and think about all those three issues, starting from the first one, the confidentiality of the asset tracking, what we need to think is that a supply chain works with inputs and outputs. And it's very important that we make sure that we're not using the same asset twice in the supply chain. So we have to create a digital twin of the asset, which should be perfect, should be unique. It has to be on the blockchain and has to represent the asset uniquely. The problem in doing so is that the asset on the blockchain is public, and so it has to be protected because otherwise I'm sharing my competitive advantage. And the same applies also for contract terms, orders, and invoices. We're not going to see that today, but it's basically another big topic that was treated several times. And if we think about that issue in a multi-party supply chain network with competing sellers and several buyers, that becomes a priority because we have to find a way to make that happen. When we speak about visibility, we have to think about a way to provide a selective visibility, not just of the asset, also of the history. It can be a piece of the data of the life cycle of the asset. It can be who has managed the asset on the distribution and the logistic process. All those things can be done on blockchain, but we want to do that with confidentiality. And we want to be able to say, okay, I own the asset, I can see the asset and I can see the history potentially, or I have owned the asset and now I can see the history of the asset itself. Or I am a third party, like an auditor, for example, which I have a specific role on the supply chain network. I was authorized by the owner of the goods. And so I need to see the end-to-end traceability of the asset itself. So it's very important to find a way to address also this complex problem on the visibility side. If we think about the business network integration, we need to go back to the ERP systems, which were the last generation of the innovation before the blockchain, right? And they do follow a very similar, let's say, approach of, let's say, what we're doing with blockchain, but they're doing it in a very inefficient way, if we think about it, because they do speak different languages. And so what we have to do is run an integration project. We have to think about mapping those data between the different systems. We need to define how we want to integrate, so through APIs or CSV files, depending on what we can do. And we have also to think about how can I make sure that I can take my data, integrate the data, and make it, let's say, sound and integer through the process of the data integration. We have to add one variable, which could be maybe suppliers owned by the final buyer of the supply chain, and that introduces another topic, which is integrating maybe different systems owned by the same company. So I have to spend money to integrate something which should potentially be integrated by the very beginning. So not being able to solve the problem could create data inconsistencies, data duplication, ultimately some data oversharing. So it's very important to find a way to do that. And if I think about a possible solution, the possible solution should be definitely a privacy-based solution. We do think that it should be a ZKP-based privacy technology, because ZK today allows us to basically use cryptography to transfer assets, to do private smart contracting. We have seen that in the past years already. And using Nightfall, specifically Nightfall, also the new version, which is going to be presented tomorrow, it's a very important step towards that privacy-based supply chain traceability on a public blockchain. Enterprises through Nightfall can tokenize the assets under privacy, have an on-chain asset back these assets under privacy, and so we have the value guaranteed by the public blockchain. And then they should be able to move those assets across the supply chain with confidentiality and with privacy. And this creates a very nice segregated environment, because basically without owning the asset, I can't see the asset itself. But it's also confidential, because on the public blockchain, we're not putting any kind of relevant information. But I can also have a traceable state of the supply chain inventory, which is reliable, because those proofs generated by the ZKP-based technology can be verified at any time. And so it's basically a strong value proposition for doing privacy-based tokenization. So how Nightfall could be the, let's say, solver of the problems that we've seen earlier on. So first of all, if you think about the confidentiality while preventing the double counting and double spending, the use of Nightfall to do asset movements plus using on-chain tokens to represent the privacy-enabled tokens creates this uniqueness, and on the other side provides reliability through all the traceability process. On the visibility side, specifically, owning a token on Nightfall gives us the power to see what we want, but we can also use privacy-based tokens to provide, let's say, a one-time authorization, for example, so you can see the data attached to a token even if you don't own the token itself, by proving that you have this token to the owner of the token itself. And if we think about the integration of the complex business networks, using Nightfall on top of a public blockchain can make us leverage the public blockchain as the common layer for the traceability across the different actors of the supply chain. And on the other side, it's going to be the common layer also for proving those tokens, which we are moving under privacy. So anyone receiving the tokens knows where to go to verify the integrity of the token itself. And ultimately, what can we do through using Nightfall? We can also decide how we want to selectively give access to the data, and thus we are creating, let's say, a very strong core for the end-to-end traceability with privacy. So with that being said, I think we are ready to see the experience from Microsoft And I'm really happy again to have Karen on board with us today. And Microsoft did a very nice experimentation phase on Nightfall using a token service with privacy, which Vito's going to talk us through in the next part of our session. So without wasting any time, I will pass it to Karen. And Karen, thank you for being here with us.
Hi, everyone. Good morning. Great to be here and share a little bit about what we have worked on within Microsoft to evaluate privacy within supply chain using blockchain. So let me jump into our experience here. Just to review the use case we were focused on and what we were looking to achieve and is important for not only Microsoft, but also the entire industry and all supply chains in general. In cloud supply chain, where we were working, this objective of mine to data center traceability is at the forefront of leaders' minds at the moment. So this is not only to address any kind of legal requirements that may be required around things like forced labor protection, conflict minerals, sustainability requirements, and other regulatory facets that may come down the pipeline that we need to prove the integrity and compliance of the entire supply chain, but also having information along this supply chain gives us the ability to more rapidly respond to changes or black swan events and model different scenarios in which we need to make our supply chain more robust. And there's a number of different facets to this. It's not only the companies involved in the production themselves, but also the logistics, how the materials change throughout the supply chain as well, whether it's the creation of a new material or the use of a material within another material and an assembly. So there's a lot of information to track at different levels if you're looking to find the entire history of how a material came together in the hardware supply chain. And what we looked at doing for our particular use case within Microsoft is we initially started with a private blockchain to suit the use case need that we had, which was effectively the ability to look at the orders that we were issuing as what we call a loan PO to one of our distributors, and then tracking the issuance of that loan PO among our end-tier suppliers for fulfillment. So in this scenario, in looking at what was supposed to only be visible to Microsoft and what we call our hub, there was that loan PO that we needed visibility to, our hub needed visibility to. And then if you look down the supply chain, the next issuance of the purchase order between the hub and the tier one supplier was to be seen by Microsoft, the hub supplier that we have, and then our tier one supplier as well for their visibility. Microsoft has visibility to this for audit purposes. But within this, we did not want our tier one supplier to see that overall loan PO. So there was a number of different situations to hide and move different levels of privacy among participants here. And all of that we wanted to store as records on the blockchain for audit purposes. So originally, using a private quorum blockchain, we were using the Tessera privacy model to achieve this. Looking at what zero knowledge technology can do in private or in public blockchains and layer 2s, we wanted to explore how we might do this elsewhere more efficiently than what we had originally built with Quorum. So we looked at representing this through tokenization because, as I mentioned, as materials move through the supply chain, there's different scenarios to represent. There is material creation, which we modeled as the minting of a token. There's ownership change along the supply chain, which involves the transferring of a token. In the event of several materials being assembled together. There was the composition of that token. And then for production usage, in which a material may be modified or changed within its use, we modeled that through composition and burning of that token to indicate that it has been used. Once it's been melted, modified, etc., that's not something in an assembly that you can radically transfer elsewhere. So we represented it as such. And an important facet of this is that layer 2 technology with all our different participants and the use of zero knowledge proof and supply chain enabled tokenization in a way that we weren't able to achieve with our previous design. There were a lot of prohibiting factors in using a different privacy model in that scenario, where we couldn't do as much with tokens before as we could with zero knowledge proofs here. So at the end of the day, the key takeaways that we had were the demonstrated comparison for our private quorum blockchain compared to the privacy we could achieve in layer 2 environments with Ernst & Young here. It is a much more future-facing approach that we see much more longevity for in the future as it evolves compared to how we were originally looking at how we designed the solution. And the tokenization model we were using here actually allowed us to model more than we were doing in the past as well, which is a nice facet because you could bring in additional use cases. You could consider different types of suppliers, different types of material in a way that we might not have been able to achieve before. And we also tested the combination of permission, visibility, and privacy in supply chain. So what's interesting here is, as compared to a retail environment where you may be seeking to achieve privacy for just a sole user on a public blockchain, and B2B and what we were looking at, it wasn't that you just wanted to have the network be not aware of what you were doing and see the visibility for yourself, but you would be working in an environment with others that you may need to share some information, but not others. So, for example, our hub supplier was seeing some information, our tier 1 supplier was seeing other information that was relevant to their business, but you didn't want to open up the whole facet of all the information going on amongst these suppliers. So it's a little bit, I would say, of a strong challenge to privacy in blockchains at the moment to allow for the privacy that's required, but also allow for the visibility that you benefit from in a supply chain environment. And it enabled us, as I mentioned, to test blockchains at the edge of their capability, which is exciting. So layer 2 technologies and the use of zero knowledge proofs for privacy are definitely the future of how we can use blockchains within the enterprise environment. And we were excited to see a step forward on our side of how we can continue to explore that realm.
Awesome. Thank you, Karen, for your, let's say, experience and telling us what was your experience using Nightfall and specifically token service with privacy. I feel you have touched several topics that still requires a little bit of, let's say, work to move from, let's say, testing out and trying things into production. But you also gave us, let's say, a sense that the path is right. We have to probably address a couple of things. One is definitely going to be, let's say, scaling up the technology, because tech and systems today are very different, heterogeneous, and also working with business processes is very important, because you have a very strong EDI-based messaging system that you use for your supply chain, and being able to, let's say, work on that and make the blockchain do something and the tokens move that creates the next level of traceability. So we look forward to see more experiences like yours, and also to start seeing maybe some piloting and production use cases for this privacy technology, because we feel it's what we need to make enterprises do end-to-end supply chain traceability at scale on the public blockchain. So really, really thank you for, let's say, telling us what you did with us with Nightfall. And before passing it to Vito, which is going to walk us through our Ops-Chain token service, what I want to anticipate is we're seeing some slide again, but we have a demo at the end, so it's going to be something that makes you understand exactly what can we do with privacy without seeing APIs. So I'll pass it to Vito, and we'll see what token service with privacy is.
Yeah, thank you so much, Fede. It's a real pleasure being here at the Global Blockchain Summit. So, based on the previous discussion, we now understand how blockchain and privacy technology can help us to address different challenges and goals. For us, one of the most important ones is to ensure privacy for businesses, allowing them to conduct transactions in a secure way and protect their data, such as pricing reserves or any other impacting sensitive business data. The blockchain adoption can be facilitated by the balance between transparency and privacy, especially in environments like supply chains, where we have different partners involved that may be also in competition between each other. Because at the end of the day, what we want is to protect business data, and we can do that by ensuring a secure collaboration between business partners. Finally, also, we can leverage the benefits of public blockchain and to also have the reliability of and the integrity of tokenization made on-chain. To solve these challenges, we have created a product, which is Token Service with Privacy. This product helps us to help businesses to work with complexities arising from the usage of privacy technologies, such as the use of cryptographic commitments, or also the balancings between the on-chain activities and also the Nightfall activities. This product also helps us to simplify the adoption, allowing businesses to make operations similarly to a traditional ERP. We have implemented APIs that makes the integration easier without having to manage the cryptographic aspect of using the privacy technology. Some example can be the creation of the product, the transfer to a third-party manufacturer in a confidential way. Also, we can combine multiple products to create new assets, share sensitive data only to authorized parties, and then complete the journey till the end of the asset lifecycle. With this product also we can complement the on-chain tokenization because, again, we don't want to lose the integrity and the reliability we have of a token that has been created on public blockchain. Also, the management of an asset lifecycle is critical because we want to create an environment that is capable of exchanging data in a detailed way, but also in a secure way. In fact, also, we have built the foundation for real-world asset management by integrating on-chain operations with Nightfall. We do this creating collaterals on-chain first and then depositing them into Nightfall to protect them and also to make them confidential. Once the token have been deposited into Nightfall, we need to activate them. And after the activation, we manage assets through privacy-preserving operations that are handled via Nightfall and the cryptographic commitments. This type of operation can be the deployment, the transfer, the transformation of an asset under specific rules, like the aggregation or assembly, and then the consumption at the end of the asset lifecycle. However, simply moving assets in a private way does not resolve all the challenges that we have. One of the key issues that that we wanted to address also is selective visibility that we have implemented in token service with privacy to simplify the Nightfall user experience and determine also who can see what. This helps us to ensure a competitive confidentiality among the participants because, again, we may have actors, and, for example, suppliers that are in competition between each other. Also, we can track assets in a detailed way by maintaining the confidentiality. And overall, this approach aligns the usage of blockchain with the real-world business needs, ensuring that the right data is available and visible to the right participant. Another key area that we have covered with token service with privacy is the supply chain messaging compatibility. We have integrated standard messages like the ADI messages to execute automatically operation with privacy-enabled tokens. For example, a purchase order could trigger a token activation, or a goods receipt could trigger a token transfer. All these features basically translate traditional supply chain messages into privacy-enabled tokenized actions. And by combining all these capabilities, the messaging system, the visibility, we want to provide a powerful tool that helps businesses to manage complex operations in an efficient way. Also, thanks to Karen, we have seen also what we have done with the Microsoft POC, and particularly with the experience of the data center supply chain traceability. In this use case, we have different actors that are involved that manage different products and materials, and this use case also requires a complex visibility. In this scenario, for example, we have the tier 4 supplier that has a downstream visibility, while the tier 1 manufacturer has the full upstream visibility. In between these two actors, we have selective privacy among all the participants of the experimentation. We can also understand how achieving this level of traceability and privacy can be difficult with only public blockchain or traditional supply chain systems. So to sum it up, maybe we can say that privacy is not just an optional feature, but it could be also a fundamental requirement for the enterprise blockchain adoption. And we wanted to build this product also to bridge the gap between transparency and confidentiality to enable businesses to operate securely on blockchain.
Yeah, and I think before diving into the demo, it's important to mention a few things. So the first thing we should mention, the way that token service with privacy was built is really trying to mimic what we can do on chain. It's even using on chain, actually, because we are tokenizing assets on the public blockchain. And so what we move, what we handle is really native blockchain tokens, which makes it very powerful for supply chains, potentially can open up also other use cases in other industries. And I see a lot of questions already coming up, so we'll come to that back later on. I also think that what we've seen is, let's say, a very strong and important aspect, which is finding the way to provide an easy integration with the product to our potential clients and to supply chain actors, because it's important to have APIs, but it's important also to use the standards on supply chains, and EDI is exactly the standard, the most used standard on supply chain. So I would say it's time for a demo, so we can take also some time for Q&A at the end. So I will pass it again to Vito.
Thank you again. Okay. So let's bring these concepts to life. So we have prepared a simplified version. Also, we will show a simplified version of all the capabilities that we have on token servicing. We'll be using a demo user interface because we want to avoid to show some boring APIs. So let's proceed with the demo at this point. So we have 3 actors here. We have the manufacturer, the assembler, and then the distributor. So the first thing that we do here is creating the continuous product using the 1155 token standard. So we create the product, then we proceed with the adding the item. So in the item page, we have to assign the token ID, and then also assign the amount, in this case 50, and then proceed with filling the metadata, so we can customize the asset that we are just creating. So we proceed with filling all the metadata. We can also and we will see also, we can also update the metadata, for example, for quality test or any other metadata that we want to add to the asset that we are creating. So we have just submitted the transaction. We have created our asset. So we have the detailed page here. We can proceed with the normal standard blockchain operation. So for example, we proceed with a burn. So we are burning 20 tokens. Now this transaction is submitting. Now we can refresh also the detail page. We can see that the quantity is updated. And again, as I mentioned, we can proceed with the update of the metadata. So let's assume that at the end of the production of an asset, we have some quality check, any test that we need to run to our product. So we can update also the metadata, and then with the latest information to our asset. So we submitted the transaction. Now the transaction is submitted. We can refresh and see the updated metadata to the updated metadata list. What we do now is we can send part of these products to the distributor. So we select the amount, and then we submit the transaction. So we have just submitted the transaction. Once the transaction is submitted, we can also proceed with the refresh page. We can see available quantity. And then we have the history page. The history page explains us all the operation that we have done with this asset. And as we can see here, we have 2 transaction hashes. So the first one is related to the on-chain transaction. The second one is to the Nightfall transaction. We have also the commitments. So the commitments here express the amounts owned by the owner of the asset. We see also the 20 because the transaction is still pending. It will be submitted soon. So we're now moving to the distributor, and we can see the distributor here received the product. So opening the product, we can see also the detail here. And opening the product, we can see the commitments, which is related to the quantity owned by the specific actor. We can now proceed to the second part of the demo. We want to create a discrete product using the 721. So we create the first product here, and then we are proceeding with the adding the item. So again, same as we did with the 1155, we assign the item ID, and then we select the amount. So the amount it's one because we are creating a discrete product, which is a unique item. So we proceed with filling all the metadata, same as we did. Okay, the transaction has been submitted. Now we can explore the item again. Okay, we can see the item here, show the details. So we can see the updated metadata, and also we can proceed further, again, also for 721, with the update of metadata, again, in case we have quality check or tests that we want to do to this particular item. So we submit the transaction. And after submitting the transaction, we are now ready to transfer this product. We can see here the history of the blockchain operation that we have done. So we have done the mint and then the update of the metadata. So we are now proceeding with the transfer. So we select the recipient, and we want to send this product to the assembler. We select the amount, and then we submit the transaction. In this process here, we are simulating basically the creation of two unique items that we want to assemble to create a new one. So we have just created the new 721 tokens that represent the product copper. Similar to the previous one, we assign the item ID, the amount 1, then we fill with the metadata. Okay, now that we have created our product, we can proceed with the exploration of the item. So we can see here, and then we proceed to the transfer. So we transfer also this item to the assembler. We can submit the transactions. And once the transaction is submitted, we can now move on to the assembler view. Here, the assembler, we can see that he received the two products, and now we proceed to the creation of the third product. In this case, it's the product RAM. In this case, we are not proceeding with the customization of the item by adding the metadata, but we are selecting the assembly feature. So in the assembly feature, we have to select the two products that we want to assemble, two or more products, also the item ID. The item, we have just created one item, so we have just one item available. And now we have created our assembled product. We can now explore to the detailed view of this assembled product. We can see the item ID, the amount. Now we can proceed to the detail page. And in the detail page here, we can see the reference of the two products that we have selected to make this assembly. And then we can finally proceed with the customization of the assembled product by adding its proper metadata. And the process here is similar to the previous one. So we just complete with the filling of the metadata, we submit the transaction, and now we have our new assembled product with its own proprietary data. We can refresh here to have a complete view.
Yeah, so thank you for the demo, Vito. It was a very nice walkthrough of what we can do. It's just a subset of what we have in terms of features, because, of course, we wanted to keep it simple. We have some nice, boring APIs that we can plug into the systems to add more value to what we've seen until now. If I have to make you a question, probably, do we think that those assets that we can trace could be treated in the same way? I mean, we've seen discrete and continuous assets. Those assets probably needs to be treated differently also in the supply chain integration, because one is consumed in a certain way, the other one in another way. So we do have capabilities, of course, to do so. And this is a very important piece, because supply chains are not really one size fits them all. It's like every supply chain is different, and we've seen that also through Karen's presentation. So I do think we have time for Q&A, and I've seen already some questions coming in. So maybe we can start taking those one by one, and I'll go and read those, and let's say we're going to be talking you through this one. So first question I see is, can this product be used in supply chain systems like in the automotive sectors? And I guess on that question, probably we can ask Vito if we have already some experiences or we have already connections on that, on the sector specifically.
So this product, to answer the question, yes, this product can be applied also to the automotive sector. So we have done the first experimentation with the Microsoft use case. And we have applied also the on-chain version of this product to different sectors, like the consumer, food and beverage, but also the automotive, not using tokenization, but using notarization. So yes, definitely we can support those type of use cases and sectors as well.
Yeah, and if I take back the regulation topics, we have the battery regulation, which is getting enforced in Europe, so European battery regulation. So being able to track batteries, the raw materials that we have for batteries becomes a very important topic for supply chains in the automotive sectors, for sure. I see the second question, which is, do we think enterprise clients are ready to adopt privacy technology on public blockchain? And this is a question which the answer is it depends, because really it depends client by client. We have seen clients which have already very complex systems, already integrated with APIs across different parties, with other parties in their supply chain. What I would say is what we did was trying to make the adoption of privacy technology on public blockchains as easy as possible. So we don't want companies to have to learn about cryptography, to have to learn about what is a commitment, even if Vito told us what it is. And it was a very easy explanation of what a commitment is. We want our customers to say, okay, I want to do traceability. I want to have blockchain value and benefits coming out of using blockchain. I want to have privacy, but I want to integrate something which is an API-based product or something like that. And doing that probably makes the adoption easier. Then the client might be ready or might not be ready. What we want to do is also help understanding if there is the readiness and what's required to get to the desired state of readiness to be able to start. So I would say it's going to depend, but we've seen Microsoft is already trying things out and testing the waters. So I guess we're moving in the right direction. So there is another question. Oh, I see, Karen, well, you had a couple of technical issues. What I wanted to ask you, Karen, is, let's say, what's your take if there is enterprise readiness, at least on Microsoft, on adopting or at least trying out those privacy technologies? What was the position on Microsoft when we did start the project? Did you feel it was ready to start testing out? Did you had any challenges, apart from the one that you already told us, of course?
Sure. Just to recap the question, is this about Microsoft readiness on adopting blockchain here? Is there a specific aspect to it?
On trying privacy-based technology and basically, let's say, being ready to try privacy-based technology, because on blockchain itself, definitely you were already ready. You were doing that before. So
yeah. That is exactly what we did with the EY team here, which is exciting. We do also have our Microsoft research team, which does publish actually a lot around privacy protocols, not only for blockchain, but elsewhere as well. So there is a lot going on at Microsoft to look at different ways of achieving privacy at the moment. And with the tens of thousands of databases that we have throughout the company, it's always the biggest challenge for privacy out there in many respects, just to achieve not only the scale that a particular application, but that a cloud environment, a worldwide company needs as well. So pushing those boundaries gives any privacy tools and technologies very high bars to achieve, and we look forward to finding more ways to get there.
Awesome. Yeah, thank you, Karen. And I see also that there was another question for you, which was basically giving a bit more details in the lessons learned from your initial experience with privacy. What do you think might be, let's say, the step forward to move into a next phase, which could be another experimentation, trying out different models, or eventually a piloting phase, or some, let's say, scale up into production, which I guess is going to take a bit of a piloting before?
Yeah, it's a good question, because it's a constantly evolving technology, and to pair that with what's needed in production and business is difficult. So you always have to prioritize supporting the business first. And I think it puts a lot of emphasis on whomever's directing the technology strategy to rigorously test what you're doing and be practical about what's reasonably achievable now that supports the business, but also is not preventing any future advancements that you may want to achieve as well, because all large companies have experienced legacy systems that are difficult to transition out of. And I do think there's strong ways that you can use what's available in privacy now to position you well for the future and prevent that difficult transition scenario. So the experts certainly have the good guidance on that, but plan for 5-10 years rather than what do I deliver next quarter is a good way to look at the efforts here.
Awesome. Yeah, you touch very good points, and I strongly, let's say, second those points. It makes sense also from my side. Thank you, Karen, for those two questions, which I think for now are what we got for you. Maybe I'll take another one, which is tightly connected, because of course what we did is a successful experimentation of privacy technology. There is a question asking which are other successful use cases of traceability which we have implemented as EY. I mentioned one earlier, which was the Peroni use case. I want to mention a couple more, which are interesting considering what we have seen today. So first one is definitely what we did in the Nordics with Ellot, which we have seen last year, tracking activities done to increase the sustainability of the world itself, so collecting plastics and proving those collections against the public blockchain to give transparency to people investing into the machines that we use for those collections makes a lot of sense if we think about it, and it's also a lot of value for the world and not just for the business. So it's a very good use case. Another use case, which I think it was a very complex one, that was again revolving around renewable stuff and sustainability, was a use case done through an energy company tracking renewable energy production and consumptions of energy, and using the blockchain to basically trace both and also trace the accounting and compensation of those consumptions with renewable energies to try to settle down the market and to balance out, let's say, the consumption and impact in terms of carbon emissions done by companies with production of renewable energies that we got through energy companies across the year. So I would say those use cases makes a lot of sense if you think about supply chains, even if in the energy we're not talking about assets, let's say physical assets, it's energy, it's not a good, final good. Speaking about assets and products, there is another question that says what type of assets or product we can trace through upstream traceability. We touched that briefly, but maybe Vito can give a bit more details on those type of assets and give us also some examples, which makes sense.
We have seen also in the demo we have created continuous and discrete products, so we can create assets that are considered as unique, but also we can create assets that can be represented as a batch. So to answer the question, we can create products at unique products, but also products that are represented at batch level. In terms of asset, well, as you mentioned, we can, for example, track energy consumption at the champion, for example, or also physical products that can be moved along the supply chain and that can be triggered with specific actions or operations.
Yeah, and maybe we can just also add a very concrete example. So let's assume I want to track, for example, a batch of beer bottles probably will take a type of asset, which is the continue asset, because we have different bottles, but they all belong to the same batch of production. If we think about, for example, a car engine, probably that's a discrete item, which you're going to put into the car, and it's going to be unique. So I feel that this difference is really subtle sometimes, but it's really an important one. And it doesn't really change the use of the blockchain itself, specifically if we use privacy. I see another question which goes around the cost. And the cost of a transaction, we have to be specific about. We have two different types of transactions. We can have a transaction on the blockchain, which is on the real, let's say on the layer one, so like minting a token on the main blockchain. The cost for that transaction really depends on which network we are using, what type of token we are creating. We have different types, fungible, semi-fungible, non-fungible tokens. It also depends on the congestion of the network, because the transaction costs can vary if we think about, let's say, the network congestion. If we consider instead a privacy-based transaction, that's pretty much different, because once the token is on the privacy, the cost is pretty much predictable. So every transfer would cost a certain amount of gas fees on the public blockchain, and specifically what goes on the public blockchain is actually the proof of a block of transactions under privacy. So we know that a certain transaction costs exactly that amount of gas and then money, of course. And this creates also a pattern for scalability, because we can make the use of blockchain like kind of public blockchain not dependent on the congestion itself, and it's really make the calculation of the total cost of ownership of using a solution like that much more easy, because it's predictable, sort of. And I think we have more questions, so maybe let's go through those two final questions that we have. The first one is on the advantages of using public blockchain for cross-border supply chain transactions. I feel we had some experience in talking with clients on that. And I think we have different topics, and maybe we'll just go through all of those together. I think we have, one is definitely traceability, seeing the assets.
Yep.
The other one is moving assets requires documentation. And it's a good trigger to talk about one of the other products that you manage, which is notarization. So maybe we can explain what we can do with notarization for that purpose. And of course, the supply chain asset movement can be done through tokenization, either public or private, depending on the needs.
Yeah, so for the on-chain side of our products, well, we don't have just the tokenization piece, but also we offer notarization services. So what we can do is write proofs on the blockchain. These proofs can be something related to a specific product or an asset, or for example, we want to notarize a particular document like, I don't know, a goods receipt or any quality certificates that we have also applied in other use cases. So with this product, so we complement the on-chain offering and also the tokenization piece, because on one side we can offer the creation and the tracking of the asset by representing this asset through a token, and then on the other side we can write proof on the public blockchain, proofs related to the asset that we have just created that are not related to the properties itself of the asset itself, but proofs that, for example, are needed on a standard business operation.
Yeah, and also if we want to think one step forward, we can think also about doing contracting and procure-to-pay processes, which is what our ops-chain contract manager can do, and we can even support that part with privacy on public blockchain. So we see a lot of different areas where the public blockchain used with privacy can be helping out cross-border supply chain transactions, and I feel we can see more and more in the upcoming years about that, because it's going to be a topic. There is one, probably a couple of questions, because I see one coming up as well, and then we're going to be closing our sessions for today. So the first question I see is a question that probably Paul Brody likes a lot, because it's, will blockchain replace ERP functionalities entirely, or will it mainly be API integrations? And I would say the answer is blockchain is going to do what ERP has done for the companies in the past, because it's changing the way companies will work together, because they're going to be using a distributed, decentralized system. It's not going to be centralized systems integrated by themselves. They would be able to trade assets and values without too many problems with privacy as well. So we've seen that over the talk that we had today. But what they will do is integrate blockchain and privacy into their system through API integrations. So they will use API integrations. Eventually, what's going to happen is they will use EDI. So they will pass EDI messages. Those EDI messages, as Vito said, will trigger some privacy-based tokenized actions, which is, let's say, probably the killer phrase that we can take away from today. And those integrations would be able to enable the use of blockchain without having to replace the current systems, which is going to be probably a bit more pretentious if we think about, because an ERP is not just doing asset tracking, it's also doing finance, accounting, and so on, which is not something that we're trying to replace. So with blockchain, what we are trying to do is improve the current processes, improve the business processes, and make them better to start with. At some point, maybe we'll see, let's say, a gradual phase shifting between, let's say, from using ERP to using blockchains, but it's going to be a process that, as Karen said, is going to take a few years. It's not something that's going to happen in the next quarter. I see another question which came, and I think that's something that we can take with Vito experiences as well, which is, can you tokenize carbon credits for trading? And I would add also something which is, what about carbon emissions as well?
Yeah, so it's another piece of our product portfolio. So what we can do is track the carbon emission, then create from this carbon emission the carbon credit tokens that are linked to the emission that we have tracked. Also, we can allocate those emissions to different products. And for example, on the other side, we can use these carbon credits for the to put those credits on a third-party markets for trading or any other operation that can be done.
Yeah, and we have seen tokenized bonds and securities starting to come. So we don't see why carbon credits shouldn't be tokenized as well. And if we think about, let's say, the whole ESG topics, we will see more and more use of blockchain for sure in the upcoming years, because having a transparent, reliable mean of authentication of those assets is very important. So I think our time is over, and with pleasure, I will hand it back to Claire for the next session.
Wow, thank you so much to Karen. I can see you on the monitor. I don't know whether you can see me, but we're very, very grateful to have you with us today, Karen, so thank you for that. And Vito, Federico, I guess, I mean, my takeaway from that is that, guys, this is real. There are assets that you can already tokenize, and there are real value stories to be had from it. But think a little bit about what your needs are and be really thoughtful around finding, I would say, the right solution, whether and what you need to have under privacy. There's solutions for that, but also there's a tremendous amount to be gained from transparency and from that traceability, depending on the metadata. So with that, I am going to now pivot